Today we're going to look at polar and nonpolar covalent bonds. David, do you remember what covalent means?
Um, well, I know the covalent bonds are the things that bond the atoms.
Yep, that's true. And what part of the atom is actually
The electrons.
good? The electrons are making the bonds. Are the electrons leaving from one to the other with covalent, or are they being shared? Do you remember?
They're just being shared.
They're being shared. Excellent. So that's what a covalent bond
if you
is.
hadn't said shared, then it would just said leaving because it's leaving from one atom to another. But yeah, technically shared.
They're shared. So, for example, if you have oxygen and oxygen, that was a bad oxygen. Yeah, just kidding. The electrons, there's actually two pairs that are going to be shared, but they're going to go around both. I want to go around you, and you, and you, and you, and you. Yep.
Make it infinity.
So now what we want to look at are types of covalent bonds. So we're going to spend most of our time today on the polar covalent.
We're going to deep into this matter.
Yeah, this is important stuff, which is why I wanted David with me today.
Oh, okay.
Unequal sharing of electrons produces what's called polar molecules. So aside from sticking a pole in the ground, is there a picture of this? Yeah. So here's a polar molecule. This is water, and one side's partly negative and one side's partly positive. So question for you, David. Aside from a pole that you can hold, like a piece of wooden long stick or a metal pole or whatever, what does polar remind you of?
Antarctic and Arctic.
Yeah. So the poles of the Earth, right? And what is it about the poles of the Earth that are different?
Something I wanted to mention. I think it's Mars has water frozen at the poles, but that's kind of a bit off topic.
A little off topic, like most of my ninth grade students. Okay. So this is our planet, and you're going to pretend that I'm an artist because that's really bad. So.
Is that a kangaroo or a bat?
It's supposed to be our planet, and this is like
the
Africa.
continents. Okay, I thought you were trying to draw something on.
No, that's just beyond. That's worse than
anyway. Faces or a vase?
Yeah. So tell me about the North Pole versus the South Pole. What's the difference?
There's a continent at the South Pole, and there's not at the North.
Yeah, but is there anything else that you can think of that has poles?
Well, actually, I think another thing is that the magnetism is attracted towards the north.
Ding ding. So he got it. So the Earth has poles, the North and South Pole, and actually this
does the sun.
Really drawn right, but does it really?
Yes, it does. That's just why they're solar flares, I think.
Really? Okay, Davey's smart. All right, so.
Well, I just saw it at Heritage Day in middle school.
Okay. So here's the other thing. All magnets have poles. So here's the south side and here's the north side, and you can see the magnetic field lines. So the idea here is these are opposites. Here's a south and here's a north, and you can tell they're opposites because if you have a magnet and you've got the north side and you put it near another one with a north side, what do they do, David?
I think that, don't they repel each other?
They do. He's good tonight. Like that. And what if you had a magnet and you had a north side?
And south side?
Yes.
Then they'll attract each other.
They will. And so if it's really strong, you got to watch out for your fingers because they're going to be trying to get right together like that. Good. So these poles are opposites, and that's the same thing with a water molecule, or it's any other polar molecule. So this is a different pole from that.
Oh, now that makes sense. I just remembered something that now makes sense.
What's that?
I wasn't really thinking through it because our science teacher mentioned that the molecules were actually in a certain format when they were froze together, like ice freezes in a certain way.
It does. It makes a crystal, and the positive side of one.
It didn't really make much sense because it didn't explain the poles. Because you don't really need to know that yet. So
So the positive side of one will be attracted to the negative side of another, and I can, if you remind me, I can kind of show you that a little bit.
No, I get it now that you showed it. Yeah.
Excellent. And so this is a picture of, not of David, but of a kid going, "This is too much."
He doesn't have freckles.
So what I want to do is show you what exactly you need to know about polar molecules. You ready? Okay, so here's a diagram of water. Each hydrogen shares an electron with oxygen, so they'll have happy, filled, stable outer energy levels. Sigh. Meow. Okay, so here's the thing. Here's oxygen. David, you probably don't remember this, but do you know how many protons hydrogen has, or oxygen?
That's a few too many for oxygen. I know hydrogen. Well,
just the things in the nucleus.
Just the bonds, and hydrogen can make. Well,
Ooh, he's got that. I'm not asking about electrons. I want to know about the
what?
charges,
Oh,
the
oh,
protons
Okay.
in the nucleus.
Sorry, I wasn't thinking
It's
about
okay.
that. Yeah. There's one in hydrogen.
Beautiful. So just one proton in hydrogen and just one proton in that hydrogen. And you don't have to memorize this, but do you know,
I
David?
don't really know
That's
the
okay.
oxygen.
So there's 8.
I know that hydrogen is one on the periodic table. So
It is.
there's
It is.
one.
Yep. And you absolutely do not need to know that there's 8 protons, but you should know it for the next few minutes while we're explaining this stuff. So you don't have to worry about these inner electrons. They're happy and stable. If you look at the outer electrons, there's 1, 2, 3, 4, 5, 6 that originally belonged to oxygen. And plus these 2 made 8. Yep, so that made the balance. And then this one belonged to that one, and this one belonged to that one. So the shared electrons are these 2 that are sharing here, and these 2. Okay. Now here's the big, well, I was going to say here's the big question, but I think my PowerPoint's to it for me. Whoops. Okay, so sorry, I do have to ask. So if you were one of these shared electrons, would you be more attracted to the 8 protons in oxygen or the puny single proton in hydrogen? So David, you're one of these 2, and you're spinning around both, right? You spin around the oxygen, you spin around the hydrogen. Would you be more attracted to these 8 positives or to the one puny, pathetic little?
Well, according to the laws of gravity, I think you'd be attracted
Well,
to it. Okay,
it's not gravity, it's
maybe
the
gravity
electromagnetic
doesn't
force.
care about this right now, but
What would you be
based
more?
on my knowledge, I think I'd be attracted to the oxygen. I probably shouldn't have mentioned gravity because that doesn't have anything to do with this.
So, well, it's one of the other forces, so it's okay. So that's right. The shared electrons are more attracted to the oxygen because it's so much more positive, and so they spend more time there. So if you're going to be one of these 2 shared electrons, you're going to spend a little bit more time up here, a little bit less time here.
And yeah, you like to talk to all the other.
Well, it's just that they're more attracted here, so they just go there.
Yeah, I know. You can't. The electrons don't talk.
These are also shared electrons between these 2 atoms, and they also spend more time around oxygen. They'll come out here once in a while, but they're going to spend a whole lot more time here. So you can see just by the drawings that I've made that the electrons spend way more time here. So the oxygen side is more. Now here's the tricky part. There's 8 positives, right? And only 1 positive here, and 1 over here. That makes 2. There's more. I know, that's pathetic. Anyway, there's more positives here, so you would think that'd be more positive. But here's the thing. Altogether, there's 10 electrons. You can pause this and count them if you want. So the shared electrons actually spend more time here. So is this side going to be more positive or negative?
It's going to be more negative.
Yeah, how come?
Because there's going to be more than 8 electrons.
Excellent. So this side's more negative, and that means the hydrogen side is more positive. Excellent. Good job. Okay, so we want to define polar molecule again. It's a molecule with an uneven charge distribution due to shared electrons spending more time on one side. So the way that you draw that is it's not an ion. You can't put a whole negative there, but you put it like this, a partial negative, meaning you put it in parentheses. That shows it's not a full negative. It means like, the electrons spend a little more time up there, but not enough for a full charge. And that side you put partial around it. You put parentheses around it to make it partial. There's this funky symbol that you can use too. This symbol means partial. So partial negative on this side.
It's a partial 8.
And that's true. And partial, oh man, I like that. I'm going to use it. And partial positive there. Here are some other polar molecules. So here's carbonic acid, and take a look at this. What does that OH remind you of? Does it remind you of anything else? Something that you just saw maybe 2 seconds ago?
Well, I know that it's supposed to remind me of water, but there's also something else with OH that I'm trying to think of, but I can't remember right now.
Well, any alcohol has OHs.
Okay, yeah, that was probably what.
So if you look at this, that's water, and we said that water is polar. And so look at this. It looks just like that. And so are the electrons going to be more attracted to the O or the H?
Okay, it's going to be more attracted to the O.
Good. Good. So this side's partially negative. This side's partially positive. David, what do you think carbonic acid would, well, that's kind of a tricky question. Hold on. We're going to go to another one. Here's another one. This is glucose, which I think I have another picture of it. Yep, here's another picture of it. Now look at this. Here's the OH. You can draw it like this as well. This is an O and an H. Here's another O and an H. See, they're all bent.
Oh, that's kind of
yeah, very funny.
Oh,
so
strange.
another OH. What do these all look like?
those all look like partial water.
Yeah, they look like a little bit of water. So that's water, and these all have that part of it. So this, let's do this. This side's partially what?
Water?
Negative.
Oh, sorry. I didn't know you were asking me about that
Partial
still.
plus. So what do you think
Okay.
water's going to do with this? You think it's going to repel it or dissolve in with it?
It's going to... Oh. Water will... Actually, I think it might depend on how you fling it at it.
Let's say you have a cup of water and you put some sugar in it. Will it all stay on one level above the water or below the water, or will
It will mix in.
it will mix in? And the thing is, the way it does that is here's, what did we say, partial negative, so the hydrogen side of water will be attracted to that.
By throw it in, I meant if you throw it in the wrong way, it's probably going to be... It might hit it the wrong, like...
Oh my goodness.
Sorry, I just wanted to mention that.
And I think that's our cue to finish. That was a lot for today. So